month of November 2022, grade 12. Question 8. In the diagram, O is the center of the circle. MNPR is a cyclic quadrilateral and SN is a diameter of the circle. Chord MS and radius OR are drawn. M2 is equals to 64 degrees. We are told that this right here is a cyclic quad. So when you add this and that, you must get 180 degrees because the opposite interior angles of a cyclic quad are supplementary. So that's going to be 180 minus 64. So this angle is 116 degrees. And then O1 is 2 times M1 because this arc SR subtends M1 at the circumference. It also subtends O1 at the center. O1 is 2 times M1. And then this whole thing should be equal to 90 degrees because SN is a diameter. 8.1.1, they want P. We said M2 plus P is equals to 180 degrees. Opposite interior angles of cyclic quad are supplementary. This means that P is equals to 116 degrees, 8.1.2. They want M1. So the whole of M, which is SMN, is equals to 90 degrees. Angle in semi-circle. So SMN, that's 90, which is equals to M1 plus M2 is 64. M1 is equals to 90 minus 64. That's 26 degrees. 8.1.3. O1. O1 is equals to 2 times M1. Angle at center is equals to 2 times angle at circumference. So this is 52. In the diagram, triangle ABG is drawn. D and E are midpoints of AB and AG respectively. AG and BG are produced to C and H respectively. F is a point on BC such that FG is parallel to CH. In this triangle, DE joins the midpoints. So it joins AD and DB, AE, and EG. So this line is parallel to that line because of the midpoint theorem. And we know that BG is equals to 2 times DE, and this is also because of the midpoint theorem. This length is 2 times that length. 8.2.1. Give a reason why DE is parallel to BH. That's because of the midpoint theorem. 8.2.2. It is further given that FC over BC is 1 over 4. So if that is x, BF should be equals to 4x. DE is 3x minus 1. And then we know that this length should be equals to 2 times DE. Okay, and then I'm given GH to be x plus 1. This is x plus 1. Calculate given reasons the length of x, the value of x. So we are saying that DE is equals to 2 times BG. This is because of the midpoint theorem. So it means that BG is equals to 3x minus 1, which is equals to 6x minus 2. Now I'm going to work in this triangle. Because there I can apply the proportionality theorem. In triangle BCH, BG over GH is equals to, so BG goes with BF, and then GH goes with FC. This is the line parallel to one side of triangle. GF is parallel to CH. BG is 6x minus 2, and then GH is x plus 1. BF, that's 4x, and then FC, that's just an x. This is 6x minus 2, which is equals to 4x plus 4. This is 2x, which is equals to 6. So x is equals to 3. You can even check if the value of x is correct, because you know that GH, which is x plus 1, so that's going to be 3 plus 1 over 6 times 3 minus 2. So that ratio should give you a 1 over 4, and it does. So it means that the value of x is correct. 9.1, that's a proof. And then 9.2. In the diagram, E, B, F, S, and P are points on the circle centered at O. GP is a tangent to the circle at B. FE is produced to meet the tangent at G. OT is drawn such that T is the midpoint of EF. GO and BO are drawn. BS is drawn through T, and then PS is parallel to GF. This angle here is equal to 90 degrees, and that is because OB is perpendicular to BG, radius perpendicular to the tangent. And then OT is a line that is drawn from the center to the chord, to the midpoint of chord EF. This angle right here should be equal to 90 degrees. Okay. And then I know that this angle right here should be equal to that angle because of corresponding angles. 9.2.1. So I need to prove that OTBG is a cyclic quadrilateral. OTBG. Okay. OBG is perpendicular to, or we can just say OBG is equals to 90 degrees. And then we'll say that the radius is perpendicular to the tangent. OB perpendicular to GB. And then OTG is equals to 90 degrees. That's because of a line from center to midpoint of chord. In other words, OBG is equals to OTG. They are both equals to 90 degrees. So this angle is equals to 90. So can we see that OG, it subtends that which is a 90. It also subtends that which is a 90. So being OBG and OTG are angles in the same segment. OTBG is a cyclic quad. This is because of the converse of angles on same segment. 9.2.2. I need to prove that GOB is equals to, so this angle is equals to S. Well, that's an easy one. So BTG, this angle is equals to this one because they are angles on the same segment. We just said that OTBG is a cyclic quad. So that line there, it subtends that angle. It also subtends that angle. So they are angles on the same segment. So we are going to say GTB is equals to GOB. Angles on same segment. But then GTB is equals to angle S. We have an F there. So these are two corresponding angles. PS is parallel to GF. This implies that GOB is equals to S because they are both equals to GTB. Question 10. In the diagram, PQRS is a cyclic quad. KP is a tangent to the circle at P. Q1 is equals to P because of the tan chord theorem. C and D are points on chords PQ and PS respectively, and CD produced meets RS produced at A. CA is parallel to QS. RC is drawn. P1 is equals to R2. These three angles are equals to each other. 10.1. I need to prove that S1 is equals to T2. Okay. S1 is equals to the whole of Q. S1 is the exterior angle of this cyclic quad. So it must be equals to the whole of Q. Is equals to Q. And this is because of the exterior angle of the cyclic quad. If I can prove that T2 is equals to the whole of Q, then these two will be equals to each other. Okay, P1 is equals to Q1, and this is because of the tan chord. And then T2 is equals to R2 plus Q2. This angle is equals to that angle plus that angle, because this is a triangle. Exterior angle of triangle is equals to the sum of the interior opposite angles. But we know that R2 is equals to Q1. So this is Q1 plus Q2, which is just simply Q. Therefore, S1 is equals to T2, because they are both equals to Q. 10.2. And then now I need to prove that ratio. Whenever we have a ratio like that, it's most likely going to be the proportionality theorem, or it is going to be similar triangles. AD, let's go and locate the length AD, the side, okay? AR, I'm just going to use a different color for AR. AS, I'm going to go back to the red. So that's AS, and then AC. So that's AC. Well, we can clearly see that we should connect those, and then we should connect that as well. In essence, we are working in triangle ASD and triangle ARC. A is equals to A because it is common. Okay, so I need to prove another angle. STR, this angle right here is equals to T2, and then that angle is equals to C2 because they are corresponding angles. I have an F there. So let's take it step by step. We are saying T2 is equals to STR, and this is because they are vertically opposite angles. STR is equals to C2. This is because of corresponding angles, given that CA is parallel to QS. Remember that T2 is equals to S1. We proved it there. In other words, C2 is equals to S1. So S1 is equals to C2 because they are all equals to T2. D1 is equals to R1, third angle of a triangle. Therefore, triangle ASD is similar to triangle ACR, angle. This is because of angle. Now we will use the ratio. AS goes with AC, so this is over AC, and then SD goes with CR, SD with CR, the first and the last letters. This is AD, that's AR. And then we are interested in AD over AR, AS over AC. AD over AR is equals to AS over AC. This is because of similar triangles. 10.3. AC is that length, okay? SD is that length, okay? And then I have AR, and then TC. So it's not going to be TC. Let's look at this triangle. This line is parallel to that one, so I can use the proportionality theorem. There I have an AR and then a TC. AR and then a TC. Okay. AR goes with RC. And then TC goes with AS. So this is AS TC in triangle ARC. This is because of a line parallel to one side of triangle. So SQ is parallel to CA. AR times TC is equals to RC times AS. Don't forget that we still have this ratio. So we want to remove RC and then AS. RC is there and then AS is that part. It means that AS over AC is equals to SD over CR. And this is because of similar triangles. AS times CR is equals to AC times SD. This is AS times RC. So we're just going to substitute with AC times SD. AR using that multiplied by TC is equals to, we are saying RC times AS is equals to AS multiplied by SD. And then we're just going to fix this. AC. So this is AC times SD, which is equals to AR times TC. Proven.